Okay, so this last section, this is a long lesson, isn't it? This last section is about surface area, and specifically surface area of pyramids and cones. But this is just a review. Remember that lateral surface area of a right solid is the perimeter of the base times the height. So I'm going to bring back our little Rubik's Cube here. And what they're saying here is that the lateral surface area is the area of this side, turn it around this side, turn it around this side, turn it around this side. It does not include the top and the bottom. Lateral surface area is just the sides and their areas put together, added up, okay? So knowing that, that would be the lateral surface area. Let's think now about a pyramid. So first we're going to consider the pyramid shape, okay? So when we're having a pyramid shape, the pyramid could have a base that maybe is a triangle or a square or a rectangle or any polygon like a pentagon. We could have a pentagon pyramid. Okay, but all of the faces, no matter which we have as the base, all of the faces are going to be triangles. This should be triangle, my bad. Triangles. All of the faces will be triangles. And our total surface area will be the area of the base, no matter what shape it is, plus the sum of all the triangular faces. So we have to add up the area of all the triangular faces and then the area of the base, and we will get the total surface area. So what about a cone? So here we have the cone formula. The lateral surface area of a right circular cone is pi rs. Okay, where pi is your approximated 3.14. Your S is your slant height, so it's this length here, and your R is your radius. Now that will give you your lateral surface area, which is the distance around, the area around the cone, but then we would have to add the base of the circular cylinder. So for the total surface area, we would have the area of the base, which is going to be a circle. And so the area of the base would be pi r squared. And then we would have to add the lateral surface area, which is all of this area up here, which is pi rs. So if we wanted total surface area of a cone, it would be pi r squared for the base and then pi rs for this area up here on the cone. Okay, so this is a picture of the problem that we're going to do now. It says the base of a pyramid is a square whose sides are 4 meters long, and the altitude of each face of the pyramid is 3 meters. Find the surface area. So here was the picture, and I decided to show you the picture because they are much better drawing the picture. But I'm going to work the problem on the board. Here we go. We have a base, and then won't we have a triangle like this on this side and this side and this side and this side? So won't we have 4 of these triangles and then one base that we have to add all together? Okay, so the area of the base, since it's 4 times 4, isn't the area of the base 16? And we have 4 of these triangles on each side coming up to a pyramid shape. And so we're going to have 4 times the area of this triangle. And the area of a triangle is 1/2 base times height. So base is 4 because it has to match this side, doesn't it? So the base is 4, the height is 3, 4 times 3 is 12, 1/2 of 12 is 6. So the area of the triangle is 6 square units. I'll have to go look at the units in a minute. So we have 6 times 4 is 24. So we have 24 square units. And over here we have 16 square units. Okay, whether they're inches or centimeters or whatever they are. Okay, so now we're going to add these two together, and we're going to get 6 plus 4 is 10. Carry the 1. 1, 2, 3, 4. 40 square. Let me go see what the units are. And the units are meters. Okay, square meters. Now, wouldn't that be the total surface area of the whole square pyramid? Okay, so we described the pyramid by the shape of its base. So it was that the total surface area is the area of the base plus the area of each lateral side, which they're all going to be triangles, and since there are 4 sides, there are 4 triangles that are going to rise up to a peak, and so we have 40 square meters is our surface area. Okay, in this very long lesson, we have one more example, and then we have 4 practices to do. So we're not done yet, but we're getting close. So this is our last example on surface area of a cone. All right, so we're going to do right circular cones only. We're not talking about any other kind of cone. But remember, the lateral surface area of a cone is pi rs, where s is this slant height and r is this radius. So that means this area that's all up here, all the way around the cone, is this. That's the formula. So we're going to add this plus the area of the base, which is pi r squared. So we're going to have pi r squared plus pi rs. Pi rs is total surface area. Okay, so now we're going to figure what this is. So now I've got 3.14 times radius squared, which is 25, plus pi, 3.14, times radius times slant height. So radius times slant height is 30. Okay, so we are going to have to work on all of this. Now we're going to go to another board. I'm going to show you a cool trick here. Notice that I have pi, and I've already put the substitution in, but I'm going to go backwards on that. I'm going to put pi times 25 plus pi times 30. Can I treat those like 2 like terms? If I had 25x plus 30x, I could add them together, couldn't I? I can do the same thing with pi. It's just I know what pi is. So 25 pi plus 30 more pi is 55 pi's. Now I've taken 2 multiplications and turned it into 1 multiplication. Much faster. So now I'm going to say 55 pi is 3.14 times 55. 55, oopsie. 55 is easy because all I have to do is multiply once and then shift it over and write it down again. 4 times 5 is 20. Carry my 2. 1 times 5 is 5 plus 2 is 7. 3 times 5 is 15. And then, since I'm multiplying by the same digit, I'm just going to move it over 1 because now it's a 50 instead of a 5. And we're going to get 0, 7, 5, 1 again. And when I add those up, I get 0, 7, 12, carry the 1, 5, 6, 7, and 1. And how many decimal places? 2. there is my lateral surface area. Since it is surface area, it is in square units. And our units for this problem were meters. So we're going to say square meters. So let's recap that problem. Okay, when we're doing the surface area of a cone, we know the lateral surface area is pi rs, and the total surface area is the lateral surface area plus the area of the base, which is a circle. So its area is pi r squared plus the pi rs gives me my total surface area. So here I had pi times 5 squared is 25 pi plus 6 times 5, 30 pi. And then I went to the other board and I said, you know what, we can do it a little easier if instead of doing the 3.14 right away, we go back to the pi and just say 25 pi plus 30 pi is 55 pi. So 55 pi is going to be pi times 55, and we did our multiplication and we added it all together, 172. Do I need the 0 here? No. 172.7 square meters. That is the last of our examples, and now it's time to come back with our practice problems. Make sure you have some paper. These take a little bit of writing. All right, so here is our first practice problem. A, find the volume of a pyramid 4 meters high if the base is a square whose sides are 6 meters long. Okay, so now we're talking about volume, not surface area. And volume is 1/3 times the volume of the cylinder that would enclose, or the right solid that would enclose the pyramid, which is the volume of that right solid would be area of the base times the height. So we're going to have 1/3 area of the base times the height. Now the area of the base is 6 times 6, or 36 square meters. So we're going to write that right here. 36 meters squared is the area of the base times the height, which is going to be 4. Okay, so we'll say area of the base is 36 meters squared times the height, which is 4 meters. And so when we multiply that all together and divide by the 3, so we'll just do divided by 3, we're going to have meters cubed. That's volume, isn't it? So we've got 36 times 4 divided by 3, but wouldn't it be faster and easier if we did 36 divided by 3 and then times 4? That would keep the numbers smaller, wouldn't it? So 36 divided by 3 is 12. 12 times 4 is 48. So we have 48 meters cubed is the volume of the pyramid whose height is 4 meters and whose base is 6 by 6 square. Did you get it right? Okay, so now find the volume of a right circular cone. So the volume of a right circular cone is 1/3 the volume of the cylinder that encloses the right circular cone. So the volume of a cylinder is area of the base times the height. All right, so now we have a right circular cone who has a 6 meters high, so we can take the height and make it 6 meters. And if the radius of the base, which is a circle, so the radius of the base is 2 meters. So since it's a circular base, the area of the base is pi r squared, where the radius is 2. So 4 times pi, 4 pi, and since it's area, it's meters squared. So we have this times 1/3. Okay, now we can multiply it all together and then divide by 3, or we could divide the 6 by the 3 and then multiply. Since the numbers aren't that big, I'm going to just multiply all the way across. So we have 1/3 times the area of the base, which is 4 pi meters squared, times the 6m. All right, so that's the height. And so now when we multiply it all together, we get 6 times 4, which is 24, divided by 3, which is 8, times pi. So 8 pi meters cubed. Now that's the exact answer, but very often your book is going to tell you to take the pi and make it 3.14. So for an approximate answer that maybe means a little bit more to us, let's take 3.14 and multiply by the 8. So 3.14 approximate for pi, we're going to 4 times 8 is 32, carry the 3, 1 times 8 is 8, plus 3 is 11, and 3 times 8 is 24, plus 1 is 25 with 2 decimal places, so 25.12. We come over to our board and we're going to put, instead of 8 pi, we're going to put 25, we'll put it down here, 25.12 meters cubed. That would be the volume that we were looking for. Okay, so find the volume of a right circular cone. Volume is area of the base times the height. The height was 6 meters, and then we're going to take 1/3 of that. So 1/3 the volume of the cylinder, that would include the cone, okay, and the volume of the cylinder is area of the base times the height. So we multiply all that together, we got 8 pi meters cubed. We ran off and found that 8 pi was 25.12 meters cubed, and that is the answer to B. Did you get it right? Find the volume of a sphere whose radius is 6 centimeters. Now this is problem C for you, and this is one of your practices. So pause your video. All right, so remember that when we have a sphere, and this sphere has a radius of 6 centimeters, okay, first we have to find the volume of the cylinder that encloses the sphere. So the cylinder that encloses the sphere would have a base and a height and be like that, right? It would be exactly touching the top and the bottom. So if this has a radius of 6, doesn't it have a diameter of 12? So the diameter is 12, which means the height of this cylinder is 12 centimeters. So that's going to be the height of the cylinder. The volume of a cylinder is area of the base times the height. The base is a circle, so the area of a circle is pi r squared times the height, and that's going to be the volume of the cylinder. But then the volume of the sphere is going to be 2/3 of that. So we're looking for the volume of the circle. So the volume of the sphere, will be 2/3 the volume of the cylinder, which is pi r squared h. So now we're going to take our r, which is 6, and we're going to put r squared is 6 squared right here. 6 squared. And then the height of this whole thing is 12 because it's the diameter. So 6 squared times 12 times pi times 2/3. Okay, so just to keep our numbers smaller, can we go ahead right now and take 2/3 of 12? 2/3 of 12 is easy, isn't it? Because 1/3 of 12 is 4 times 2 is 8. So can we just take this out and put an 8 in? So we're going to have 36 times pi times 8. And that should be our answer. Okay, so we're going to have to multiply all this out on another board. make it a little easier, I'm going to multiply the 36 times the 8 first. And I'm going to get 36 times 8 is 48. And 24 plus 4 is 28. 288 times pi, 3.14, is going to be 8 times 4 is 32. 8 times 4 is 32, 33, 34, 35. And 2 times 4 is 8, 9, 10, 11. And then 288 times 1 is just going to be 288 moved over 1 with a hole. And 288 times 3, oops, I don't have enough room. So 8 times 3 is 24. Carry the 2. 8 times 3 again is 24. Plus the 2 is 26. Carry the 2. 2 times 3 is 6, 7, 8. So we have that one right there. So let's try to add those, even though I didn't leave much room. So we have a 2 and a 13, carry, and an 8 plus 4 is 12, 13, 14. And then, okay, so that was that row right there. 6, 7, 8, 9, 10. And an 8 plus 1 is 9. So if I didn't make any mistakes, we have 2 decimal places. So 904.32. Now I'm going to check that with my calculator real quickly. And I did the work on my calculator and I got the exact same answer. So we did a very good job. And this would be the volume of the sphere. So let's go back here. 904.32 goes right here. And that is a volume, so it's going to be centimeters cubed. And there's our answer. So to find the volume of the sphere, we find the volume of the cylinder, and we take 2/3 of that. The cylinder's height will be double the radius, because it's the diameter. So we did the volume of the cylinder was area of the base times the height. The area of a circle is pi r squared. Height was 12. That got erased, 12. So then we take 2/3 of that to get the volume of the sphere. 36 times 12 times pi times 2/3 gives us 904.32 cubic centimeters. One more practice. This is our last practice. Land, this has been a really long lesson. Find the surface area of a pyramid whose base is 5 foot square and whose triangular faces have an altitude of 10 feet. So we have 5 foot by 5 foot is the square base, and we're doing the surface area, and that includes the base. And then each triangular side, so we should have a triangle here, 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 all coming up to a point. And so we have 4 of these triangles, and the triangle's base should be 5 because it's got to meet with that side, 5 feet. And the altitude should be 10 feet. So the area of each triangle is 1/2 base times height, or 1/2 of 50 is 25 square feet. So since there are 4 of these, that's going to be 25 times 4, or 100 square feet, plus 25 square feet is 125. So we'll put 25 plus 100 square feet is 125 square feet. So when we're doing a pyramid, it's going to be 4, since this was a square pyramid, 4 of each one of these triangles going up to the point. And so the area of each one is 1/2 base times height. The 1/2 of 50 is 25. So 25 plus 25 plus 25 plus 25 is 100 square feet. Add the base, which is 25 square feet, and we get 125 square feet. And we are done with that very, very long long lesson. And this is Mrs. A. And may God bless your day.